Hi, welcome to IT and Automation, and in this series of Argo CD. So today we are going to look into details that we didn't touch upon in last videos. So if we recap last three episodes, which was based on Argo, we looked into installation side of things and Helm-based installation, manifest-based installation. We created some apps. We saw it syncing on the cluster. Today I wanted to touch upon a bit more in details around these options that you can set. So without further ado, let's look into creating a similar app. So here we'll use the same app, which is an open source repository which contains the apps provided by Argo project itself, and we will give it a default name and sync policy. So what exactly is sync policy is how do you want your manifest, the application, to be synchronized into the cluster. If you set manual, it will not make the change itself, but it will reflect as there is a diff, and you would have to apply it manually. Whereas if you do automatic, if the desired manifest is not in the same state in cluster, it will apply it as well. So you are asking Argo to keep the state of your Kubernetes in a true state as mentioned by this repository, which will use a path inside this repository in our case, but that would be the same logic. So let's put it manual for now. And what is set deletion finalizer? So if you look into this tooltip, it says the resource deletion finalizer will be set on application. Okay, and it is potentially destructive. So what exactly is this? So in Argo CD, that option means it is a mechanism which is used to ensure that resources are deleted properly upon cleanup. Finalizer can be set on applications to make sure that all of the associated resources are properly removed. So we are talking here about not leaving behind orphan resources, not leaving behind resources to be a zombie. So by setting a finalizer, you ensure that all of the child processes or resources like self-deployment, maybe services, config map, whatever it may be, are deleted before the application resource itself is deleted. So that is to avoid that conflict of orphan resources being around. And it has importance, right? It has importance of that what we just talked about around orphan resources, as well as controlled cleanup. So you have this control over the cleanup. It will give a reliable state of the cluster, as well as it will be consistent. If you wanted to see how that works, you could literally do this and say edit as YAML. That's what it is going to set in the application. There are a few considerations as well you need to make. Namespace and scope. Make sure that the finalizer is set within the correct namespace and the scope of your application. Dependency management. Be aware that dependencies between resources, and ensure that the deletion order is defined by finalizer and respects these dependencies. And obviously the monitoring part of it. Argo comes with lots of plugins to do the monitoring and alerting. You got to monitor and audit your resources to ensure that finalizer are functioning as expected. With that in mind, you could use that option to have a better control and clean up. So that is set delete finalizer. So moving on to the next option in sync options here, which is skip schema validation. So what does that mean? Skip schema validation for application is if you want to bypass validation check that are normally performed on manifest before it gets applied to the cluster. You would not want to do that in general scenario, but there can be certain usefulness as well. If you're dealing with custom resources or an extension that Argo CD validation does not recognize, or when you are confident that manifests are valid and you want to expedite the deployment processes. General view would be you want to validate your schema rather than skipping the schema. So yeah, if you set that option, what it does is it will flag that sync option and it will skip the schema validation. Again, you would need to be aware of potential risks, right? And in general, it is always best to use the validation. And again, your call with the testings and with the necessary pipelines in place, you may have condition where you want to skip the validation. So moving on to another option here, prune last. Prune last feature is an option that allows you to configure the order of operation. So during synchronization process, that resources pruning occurs after other sync actions. This can be important in a scenario where the deletion of resources should be deferred until after a new or updated resource have been applied. In that case, you would want to use prune last. This ensures smooth transition and avoid any disruption or downtime. If I have to come with an example scenario, I would say where you are updating an application that includes a database deployment and an associated service. If the service were deleted or pruned before new database deployment is applied, this could cause temporary disruption in connectivity. So by using prune last option, you ensure that new database deployment is applied first, followed by any necessary deletions, thereby avoiding any connectivity issue, right? So another option is respect ignore differences. Respect ignore differences is used when you may have differences coming from a different part of the system. One of the example that I could come with the respect ignore differences config would be when you have replicas being changed by something else, likes of HPA. Maybe you have auto scaling feature which increases the deployment of your replicas, but your manifest has replica count, and in that case maybe you want to respect ignore differences, and many other reasons there could be where where there is a multi-dimensional merge happening between live state, desired state, and you want to respect those differences, then you would use that option. Auto create namespace, as it says, if there is a namespace mentioned and that doesn't exist, it will create it wherever the app is running. Apply out of sync policy. It is to apply any out of sync policies. It doesn't need any further explanation, I guess. And server side apply. Moving on to the next one, server side apply. It is essentially a method for applying changes to Kubernetes resources that leverages the Kubernetes API server's ability to manage and resolve conflict in the resource definition. So server-side apply is particularly useful for declarative configuration, as it allows multiple controllers and users to manage the same resource without interfering with each other. And Argo CD supports server-side to manage Kubernetes resources more efficiently. This method may be seen as an advantage. So Kubernetes server-side apply would help resolve conflicts by tracking the field manager, batch efficiency, instead of sending the entire resource definition. Only the changes are sent to the Kubernetes API server, which then gets applied. And declarative management, right? Nature of GitOps. And benefit, same thing again, state tracking, merge capabilities, improved concurrency. Another use case of server-side apply can be when you have restrictive RBAC controls, where you have to create or update or apply resources based on resource name. Create doesn't necessarily understand the resource name before it gets created. So server-side apply, if you're doing server-side apply and you have RBAC restrictions, it would work in that scenario as well. Okay, so moving on. Prune propagation policy. How do you want to prune the propagation? If you want to do it on a foreground, background, or an orphan. These can be useful to reconcile the state of Argo for any reason if it is not exactly what you expect it to be on. Replace and retry feature is option when you may want to replace an existing resource instead of applying update incrementally. In that case, you would be using kubectl replace. There can be a situation where you do not want to run that for any reason if that existing pod cannot be removed. You can think of a DNS resource running on it. And retry is how much often that you want this policy to be retried. I'm not sure on top of my head, but maybe we are looking at 5 as a default. And sources, as you already seen, which Git repository it comes from, repository URL. When you give that repository URL, it is smart to go and look for all of the paths. In this case, we say it is apps that we want, and it could be any other here, right? If it is a mono, you see all of these options there. Destination, which cluster is this application running on? It could be group of clusters as well. So that sort of configuration we can look into in the future, where that cluster name in cluster or it can be applied across the board as well. So here destination, it goes into this particular Kubernetes cluster, which is the in cluster that we are currently testing with. Namespace Argo demo, and we will say auto create namespace. Namespace Argo demo, we want to install that on. And Helm values are if you want to pick anything else there as in Helm values, and any other values you want to put. If you were editing that, all of those options came here, and these could be based on a tag. There are other advanced configurations if you're doing this installation across the multiple servers and things like that. So if I save this, it should create. So if you look into this here, those are the resources that Argo CD would have tried to create. And if I sync that, it will create resources in Kubernetes cluster. What I will do is quickly show the option of this application in detail. We had an option of, in summary, enable autosync. What we will do is we'll enable autosync, go on here and say sync this one, synchronize that. It created the resource. And if I go and do kubectl K9s, let's do K9s and look into some of these resources, why it is still in progressing, right? Progressing, and it says it's pending deletion. Pending deletion would be most likely due to the finalizer, but let's have a look. So what was the resource it was pending deletion in is in a namespace Argo CD, there is Helm guestbook application. So if you look into applications, Helm guestbook, that's the application. And when was that created? That's most likely from my last installation. So that's why it is not being not created another one. because there was a pending deletion from last time. Okay, here we go. We tried deleting that because of the finalizer. It wouldn't let us. Let's remove that finalizer. It's gone. And is there any other resources that Hamburg, all of those applications, right? So here, this Hamburg is also old one. We'll remove that finalizer. We will remove this finalizer as well. You can, by the way, there is a video about finalizer that I did long time back. I'll attach that link in the description. You don't have to come here and do this removal. You could do it. You could do it out from command line as well. I'll attach that in the description. So here now things are in missing, and that should be, if we sync that, just for the out of sync for now. There we go. It is enabled, right? Prune resource enable. Okay. So let's try to delete resource from cluster. Let's say you are you have a cluster which for some reason someone goes and removes the resource from there. What happens? That resource is in terminating state, and another one comes up, right? We did not do anything. Just because we had self-heal and automated sync policy in automated state, you saw that resource coming immediately. And if you were managing all of the underlying application through the Argo, now you have less disruption. So that's how Argo uses the sync policy. If I go and disable that sync policy, and so that behavior, if we look into that behavior by disabling the sync policy here, reload, it will just stay in here as a missing, right? And you could sync that and get the resource back. But that's the difference between automated and the manual sync. Yeah, so that's pretty much it for today, and I will see you in next video.